So today I'm going to be presenting earthquakes and tsunamis for my geology final project by me, Tatum Retke. Starting off with, what are earthquakes? As you can see in this picture, you have before in this little town and after. So before the earthquake, as you can see, it is peaceful, it's quiet, and there's no disruption to it. But once it comes to earthquake, then you can see all the buildings are destroyed, the structures, even the road is gone. And many people have probably lost their homes because of this. The definition of an earthquake is a violent shaking of the ground that can cause a destruction and damage to the earth, either within the crust or from a volcanic eruption. They are mostly caused by convergent boundaries, which are oceanic continental crust, or boundaries. They occur when one plate is composed of continental rocks and the other is composed of oceanic rocks. So some steps of an earthquake that actually happen, I'm going to use the stick as an example. As an elastic rebound, so if you take a stick and leave it flat, its original position than it was before the earthquake happened. So before the earthquake happens, everything's fine, it's stable, and then once it has a buildup of strain, then the stick starts bending. And so once the stick starts bending, then the buildup of strain happens. And then when the earthquake happens, the stick ruptures and breaks into two pieces. And then after the stick is broken, the strain of all the energy is finally released. So the tool that they use to measure how earthquakes get or how big they get is a seismograph. It determines the location of an earthquake to measure how much energy is released and also how big the magnitude can get. So we have P and S waves. P waves go back and forth, and as you can use an example, as Professor Massey used in his class, he used a slinky, so he brought it back and forth, and so that's why the P waves are also the fastest, because when you bring it back and forth, that's obviously the fastest. And then S waves travel up and down, so when you use the slinky, you just go like this and it travels slower, so that's why it's called the secondary to P waves. And then those are so you have body waves and surface waves. Body waves travel through the Earth's interior, and then surface waves actually have the most destruction to the surface, and they move along the surface of the Earth. So going on to tsunamis, what are tsunamis? As you can see in this picture, you have, it's kind of a little over dramatic, but it does it does have a very big destruction to it. So as you can see, the cars are out or are getting destroyed. The boats will come in, it'll destroy anything in its way. So what they are a series of waves created by underwater disruption, like a large earthquake, landslide, and volcanic eruptions. So anything that's disruptive under the water, that's how they are created. So in this case, they're usually caused mostly by earthquakes. Also, just like earthquakes, tsunami can destroy buildings, injure many people, and leave people homeless. So they usually travel 20 to 30 miles per hour with waves either 10 all the way to 100 feet high. They can cause flooding, power, communications, and also the water supply would be gone. Anywhere along the U.S. coast, Pacific coast, and the Caribbean have the greatest risk. So how to tell a tsunami is coming? If there's severe ground shaking and force from an earthquake, that's how you know you should definitely get to a higher ground, or a volcanic eruption. So the fall and rise of the water level in the ocean, if the water level from the surface is going back or it's going towards the middle of the ocean, then that's how you know that you should also get to a higher surface. There are a series of waves that come in, and so the first one might not be the biggest, but it sure is the starting point and can build up to a massive wave that can destroy anything in its way. So a little example of a tsunami is that, imagine if you're giving your kid in your house a bath in a bathtub, and they like to have fun in the bath, and they decide to splash a lot. So the splashing that your kid is making is coming out of the bathtub and getting the floor all wet and making a mess. So the child would represent the earthquake, and then the water that he's splashing is representing the tsunami and getting out of the ocean, which is the bathtub. and onto the surface of the earth, which is the floor, and getting it all wet and maybe destroying the buildings or the ground. So some of the biggest earthquakes and tsunamis that we have is one, the Japan tsunami of 2011. It happened at March 11, 2011, a record breaker of 9.0 earthquake, and it shook Japan. More than 120,000 buildings were destroyed, and the financial damage ended up being $199 billion. Yeah, so there were 15,890 people that were dead. The second one we have is 2004 Indian Ocean earthquake and tsunami. So that happened December 26, 2004 with a magnitude of 9.1. It struck the Indian Ocean near Indonesia, which created a huge tsunami which killed about 300,000 people. And it was known as the deadliest natural disasters ever recorded. So how this was caused, it was caused when the Indian plate was subducted by the Burma plate, and that which triggered a series of tsunamis. The Great 1906 San Francisco earthquake, that just happened here, since we're in Hayward, so that's an hour away or 45 minutes away. That happened in April 18th, 1906, which is about 5 in the morning, and it was a magnitude of 7.9 that, it was 45 to 60 seconds, so a short amount of time, but in that amount of time, it was a great amount of damage. It was destroyed more than 28,000 buildings, and it killed more than 3,000 people, and also the damage ended up being $500 million. The last one that we have is the Chile earthquake of 1960. It happened May 22nd, 1960. It was off the southern coast, and it was the largest earthquake to ever be recorded in the 20th century. It was a magnitude of 9.5, so over 5,000 people were killed, and over 2 million people were left homeless. So after the earthquake, a huge tsunami came in because usually when an earthquake happens, it has to have a magnitude of 7.5 in order to create a tsunami. So when the tsunami came in, it was 35 feet, and it killed more than 1,000 people. So we have the San Andreas Fault, which I thought it was important because we're very close to it. We are on the Hayward Fault, but since it is in our area, I thought it would be good to explain. As you can see in this picture, you have the red line that goes from Eureka all the way to Brawley. So in this direction, or in this line area, we have Daly City, San Francisco, San Jose, Santa Cruz, all in our area. And we just have to be careful because if it does go off, it could be one of the deadliest earthquakes ever. So it's a boundary line between the Pacific Plate and the North American Plate, and it splits California into two pieces. It's also a transform fault, which means they can slide against each other in order to make the earthquake. And so if this fault line goes off, like I said, it could be one of the deadliest and disastrous earthquake in the world. And that is it. Here are my references, and